Problem 8. Sarah makes a staircase out of toothpicks as shown below. This is a 3-step staircase and uses 18 toothpicks. How many steps would be in a staircase that uses 180 toothpicks? So you notice that this is a step. It's a very ordered pattern. So if there's a very ordered pattern in the construction of this step, then perhaps there's an ordered construction of the number of toothpicks needed for each level. And by level, I mean the number of steps. So this would count as the first step, second step, 3 steps, and etc. What happens for the first step? For the first step, we have how many toothpicks? We have 1, 2, 3, 4. We have 4 toothpicks. Now let's consider level 2. For level 2 is the same thing as the first layer, but then we must add on 1, 2, 3, 4, 5, 6. We must add on 6 more. So if I clear that, this would be 6. But the 6 is added on to the first, so that's 4 plus 6 total toothpicks. What about layer 3? Well, for layer 3 is 4 plus 6, the amount of toothpicks in layer 2, but we must add on 1, 2, 3, 4, 5, 6, 7, 8. We must add on 8 more. So now you see a progression here. That's very arithmetic. And it's an arithmetic progression, right? It's 4 plus 6 plus 8 plus etc. And this sum gives us the number of toothpicks at each layer. Consider, for example, I want to find the toothpicks in the first layer. I just take the partial sum of one term. But then if I want the number of toothpicks in 2 layers, I take 2 terms. If I want the number of toothpicks in 3 layers, I take 3 terms. And you see where this is going. By deductive reasoning, if we want to have, for example, 180 toothpicks, well, we simply add it up all the way until we get 180. But more specifically, if we add all this, we get the number of layers. But that's irrelevant to the question. All we need is that this sum represents the total number of toothpicks, so thus we must want it to equal 180. But how do we know what this sum is going to be, which is the last term? Well, the last term follows the arithmetic progression. So that means a of n is equal to the first term plus n minus 1 times the common difference of 2. So that's 2n plus 2. So that means that we must add some term all the way up to 2n plus 2 for some constant n, such as n is equal to 10. I'm not saying that it is, but for some constant like that. So now that we have this, we have a arithmetic sum. So use the summation formula. The summation formula is the first term plus the last term times the number of terms. Well, how many number of terms are there? Well, we have 1, 2, 3. Well, we actually don't know. So let's just use x for now, and then we divide this by 2. This is equal to 180. So that means 6 plus 2n, right, times x divided by 2 is equal to 180. But is there a better way to determine the term number? Well, this is 2. Well, this is what? That's 2 times 2. That's 3 times 2, right? That's 4 times 2. So there isn't a good way. Well, let's just leave it for now, right? And let's divide 2 to here and simplify. So that's 3 plus n, right? 3 plus n times x is equal to 180. Now we just define the number of terms there are. Well, let's suppose that actually, how many steps would be needed? So let's just plug it in, right? The number of steps would be equal to the number of terms. So let's say n is equal to 10, right? If n is equal to 10, then that's 13x is equal to 180. Obviously, that doesn't work. N is equal to 11, right? We have 14x is equal to 180, right? And that obviously doesn't work. And it's equal to 12. Well, that becomes what? That becomes 15x is equal to 180. And that obviously works because x is equal to 12. Therefore, you have 12 layers within your thing, which would work. So that means your final answer would be answer choice C.